Hi everyone, good evening. So this is your teacher, Mr. Carlos. I want to go over again with the rates of reaction. So I want to discuss again these rates of reaction. I know you've done this before, but I'm sure some of you forgot the concept of the rate of reaction. So I will try to make this very simple, the rate of the reaction. So especially um, when we are interpreting graphs, okay, graphs. So there are a lot of question that comes that involves graphs under rates of reaction. So okay, we're gonna go over with those questions after this PowerPoint presentation, okay. So why are we learning these rates of reaction? All right. So what is the importance of this rate of reaction? So say for example, you want to speed up a chemical reaction. How are you going to do that? Okay. So your knowledge in the rate of reaction will give you an idea. Say for example, you have a reaction and it's very slow. You want to speed it up. What are you gonna do to speed it up? Okay. And if it's very fast, okay, and you make it slow, how can you control the reaction? Okay. So that's why we're gonna talk so these are the importance of the rate of reaction, or knowing the rate of reaction, because there are stuff that you wanna speed it up, and there are reaction that you wanna control it or slow it down. And how are you gonna do that? Using our knowledge here. Okay. So there are also reaction that involves temperature. Okay, so if you increase or decrease the temperature, will it be safer? Will it save energy? So things like this. Okay, so we're gonna talk about what that's why we're gonna learn about the rates of the reaction. Okay. So, before we go over with the rate of reaction, we're going to talk first about the collision theory, okay? So, this collision theory explains, okay, how the reaction works, okay? How the reaction works, all right? So, for a reaction work, all right, for any chemical reaction to work, okay, so two things must happen. First, the particle needs to collide. Need to collide. Okay. So without collision, there will be no reaction. So the more collision, the faster the reaction. Okay. So that's why you need the particle to collide, otherwise there will be no reaction. Okay, so it is very important for the particles, for the reactant. These particles, I am referring to the reactants. Okay, so say for example, I have A plus B will turn into C. Okay, so for a reaction to take place, for this reaction to take place, A and B must react or must collide, all right, so that they will turn into C. Without A and B colliding, they will never turn into C. Okay, so that is what collision theory is saying. Particles need to collide for a reaction to happen. Okay, and then of course the second one, so that's why but not all collision lead to reaction. So that's why here in number 2, okay, so we have number 1. What was the number 1? All particles must collide. Okay, but here it says here, not all collision leads to a reaction. Why is that? It's because particles that are colliding must have activation energy. Okay, or EA. So the particles that collides, each particle must have activation energy. Okay, so without activation energy, or without enough activation energy, even if they collide million times, they will never react. Okay, they will never start to react, they will never form a product. Okay, so again, when an A plus B will turn into C. So the first thing in collision theory, what does it say? In collision theory, A and B must collide. All right? And whenever they collide, A and B must have activation energy for them to turn into C. Okay? So those are the two things collision theory says. All right? So it says here particle must collide before reaction can take place, but not all collision lead to a reaction, because reactants must have at least minimum amount of energy, which is called the activation energy, for them to react. So those are the two important things about collision theory. Okay, so here it says here that even if they collide, not enough energy, no reaction, no chance of reaction. So here they collide, and then at the same time the particles they have enough energy. So that's why this can form a product. Okay, so this is what we call a successful collision. Okay, so successful collision, for a successful collision to happen, that is wrong spelling. What is this for? Okay, so for a successful collision to happen, okay, for a successful collision to happen, the particles that are colliding must have enough energy, and that energy is what we call what? Activation energy. Okay, and if they ask you what is an activation energy, so this is the minimum amount of energy that the particles must have in order to react. Okay, again, what is activation energy? Minimum amount of energy that the reactants must have in order to react. Okay, so that is the collision theory. So according to collision theory, to increase the rate of reaction, you therefore need to what? So you need more frequent collision. The more collision, the faster the reaction. Okay? So, more collision, faster reaction, or increase the particle speed, have more particle present. Okay? So that's why if you have wait, let's go back here. What is going on? I want to go back here. All right, so more frequent collision, the faster reaction. So say for example here, I have two bags, and these are the particles. So between A and B, which one will have a faster reaction? It's gonna be B, all right? Because more particle, more collision. Okay, less particle, less collision. So for you to increase the rate of reaction according to collision theory, you have to increase the number of particles. Okay, so more successful collision, or more energy. So say for example, I have here two bags again, which they have the same number of particles. What is going on? Okay, so I have two particles, okay, or two bags, so which they have the same number of particles, okay. But the first bags, which is called bags A, and this is bags B. So the first bags is that the temperature is 10 degrees Celsius. Here there is 25 degrees Celsius. So they have the same number of particles, but inside they have different number of temperatures. So which one would you think will react faster? Is bags B, okay? Because they have a higher temperature. What the? So we have the higher temperature, okay? So they have the higher temperature. That means the particles have a higher energy, okay? So a higher temperature means the particle have higher energy, all right? And so if the activation energy is 25, then once they collide, they will have a successful collision, okay? So, how do we increase the rate of reaction? So, for us to increase the rate of the reaction, we must do the following. Okay? We must do the following. So, we have to increase the surface area. We know that of solids, alright? So, we have to increase the temperature because the increasing temperature will increase the rate of, the activation energy. When we add a catalyst, what happened when we add the catalyst? We lower the activation energy, okay? So later on, I'm gonna explain this add a catalyst. And then when we increase the concentration of reactant, we are increasing the number of particles, okay? So that's why we when we increase the concentration of reactant, we increase the rate of reaction. Then increasing the pressure of any gases, and then we can shine a light too, okay? So we're gonna talk about one by one what are these for. But these are the factors that increases the rate of the reaction. So these are the things that you can do for you to increase the rate of the reaction, okay? So let's do this one by one. When we increase the surface area, increasing the surface area increases chances of collision, okay? So more particles are exposed. So that's why we increase the rate of the reaction, because more particles are exposed, okay? So that's why powdered solid reacts faster than large lumps, okay? So these are the the powder ones. So when you have a powdered compared to a big chunk of reactant, you will definitely have an increased rate of reaction compared to this one, okay? It's because the particles here are exposed, okay? The particles here are exposed compared to this one, okay? So you can also no, this is an example. So that's why a catalyst are in a finely divided form for this reason. So that's why most of the catalysts, they are in powder, okay? So that the rate of reaction will be faster, okay? So here, this one have a low surface area, and the other one has a higher surface area, okay? So that's why when you slice a big chunk of reactant into smaller pieces, you are increasing what? The surface area, okay? So if they ask you, if they gave, that's why when you are cooking something, you slice the vegetables or the meat or the chicken, okay? Why do you need to slice chicken, okay, or meat or the vegetable? So it will be cook faster, okay? So this is the reason why you are slicing it. So when you are slicing it, you are increasing the surface area, right? So I'm sure you know that because you love to cook. Now, increasing the temperature, okay? So this one, when we increase this temperature, okay, of the reactant or of the reaction, you are increasing what? What are you increasing when you increase the temperature? You are increasing the kinetic energy of the particles, okay? So of the particles, so when you are increasing the kinetic energy of the particles, what happened to the particles? They move faster. So if they move faster, therefore they collide more. Okay? Collide more. All right? So aside from increasing the kinetic energy, what other benefit of increasing the temperature? Okay? You are increasing the activation energy of the particles. Okay, so these are the two benefit when you increase the temperature of your reaction. So when you are increasing the temperature of the reaction, two things will happen. You increase the kinetic energy of the particle, and when that happens, the particle will move faster, and when they move faster, they collide more. Okay, and then aside from that, when you are increasing the temperature, you're also increasing the activation energy of the particle. Remember, in collision theory, what do we say? That for a successful collision to happen, particle must have enough activation energy. And how do we increase the activation energy? We increase the temperature, okay? So copy that, post it, and then copy if you want or if you need to. But anyway, I am requiring everyone who watched this to copy whatever I just wrote and whatever is on the slide. Increasing the temperature increases the rate of the reaction. Particles get more energy, so more overcome energy barrier. So this explains activation energy, and this explains kinetic energy. Okay? This is very easy. All right, so this is now a very very good graph. So we did this before. So this is the activation energy, and this is the energy change. Okay, so let me just write that down. Energy change. Is this exothermic or endothermic? It is exothermic. And if they ask you why, because the energy of the reactant, this is the reactant, the energy of the reactant is more compared to the energy of the product. Okay, so this is the energy of the product, and this is the energy of the reactant. So this is the activation energy. What is the activation energy? Look at the graph. Okay, look at the graph. So here for the reactant, to become a product, for a reactant to become a product, they need to reach this point. Okay? They need to reach this point. What is this point? This is the activation energy. Okay, look, this is the activation energy. It says here that for the reactant to become a product, the reactant must overcome. What does overcome means? So they must go across the activation energy for them to become a reactant. Okay? So that is very, very simple. Okay? And for the reactant to overcome the activation energy or jump the activation energy, they must have that energy. Okay? So they must have that energy for them to become a product. Otherwise, they will never gonna become a product. Okay? All right, so say for example, let's go over with that. How do I change this? Oh my god. All right, so let's continue with this one. So say for example, the activation energy is 100, okay? And let's say the energy of the reactant is 50, okay? So the energy of the reactant must gain 50 more. They must gain 50 more to reach the activation energy. If they cannot gain 50 more, then they will never become a product. Okay, they can never go across this barrier. Okay, there is a wall here. There is a wall that the reactants need to escape or to jump for them to become a product. Okay, and that wall is what we call what? Activation energy. And for them to jump, they need to gain more 50. All right, so that is activation energy. So during a reaction, the enthalpy, a form of energy, rises to a maximum then falls. Okay, a minimum of energy is needed to overcome the activation energy. So only reactants, so here a minimum energy is needed to overcome the activation energy. Only reactants with energy equal to or greater than this value will react. Okay, so say for example, if you have that, look, this thing, I'm gonna go back to this again. This will try to go across the barrier, this one. So if this ball have enough energy, then it can go across. Let's see. Yes, it does. How about what is going on? All right, so if they don't have enough energy, they will never get over the barrier. So let's see. This one, the ball, it does not reach the activation energy. Okay, so the minimum energy it requires for them to become a product. Okay, so if they have enough energy, they will get over. So that's why if this have enough energy, what will happen? It can go across the wall. Okay, so that's why you need an energy for a reaction to happen, and that energy must come from increasing the temperature of the reaction. Okay, so that the particle will gain energy, and if they gain energy, then they also gain or they also increases the activation energy. All right, if more energy is given to the reactant, then they are more likely to react. Okay, again, copy this slide. So for you to copy, pause it. So when you are adding a catalyst, so what is a catalyst? A catalyst provide an alternative reaction pathway with a lower activation energy. Let me explain that. So say for example this graph, okay? So this graph, this particle, for them, this reactant, for them to become a product, they need to go across this, okay? This wall, all right? But if they don't have enough energy, it can never go across, okay? That's why you are adding a catalyst. Look, this is the graph when you are adding a catalyst, all right? When you are adding a catalyst, so this is the activation energy. This is the activation energy of a reaction with a catalyst, and this is the activation energy of a reaction without a catalyst. All right? So which one have a lower activation energy? Okay? The one without a catalyst or the one with a catalyst? So this one. So they have a lower activation energy. When you add a catalyst to a reaction, what does the catalyst do? What will the catalyst do is they find a different pathway. Okay? They find a different pathway, and that pathway leads to the same end, and that pathway have a lower activation energy. Okay? So say for example, I have A plus B. All right? So this A plus B, okay, without a catalyst, they will go this direction. So this is without a catalyst, okay? So they will go to this direction to become a C, okay? But if without, actually, let me give you a different, let me write a different, let me explain in a different paper. Okay. So this is without a catalyst. Okay. Say for example, I have A plus B. So A plus B without a catalyst, they will directly go to become a C. Alright? So in this pathway, this direction, let's say you need 1000 degrees Celsius. Okay? But for something with catalyst, so A plus B, first they will turn first into D, and then the D will later become a C. Alright? So you see, they ended up having the same product, but their way is different. Okay, let's say this arrow you only need 50 degrees Celsius, and this arrow you only need, let's say, 5 degrees Celsius. Okay, So which one have a lower activation energy? It is with catalyst. Okay, so if you have a catalyst, they find way that has a lower activation energy. But if your reaction is without a catalyst, you will directly go straight forward. Okay, A plus B will turn in C right away. But this reaction have a higher activation energy. Okay, so that is why you are adding a catalyst. When you are adding a catalyst, all right, when you're adding a catalyst, the catalyst will find a way, but that way will lead to the same product, but that way has a lower activation energy. All right, unlike without catalyst, you will go directly straight forward. Okay, so let's go back to the this one. So that's why here you have a higher activation energy versus a lower activation energy. Okay, you see it's faster. A catalyst remain chemically unchanged. The catalyst will not react to the reactant. Okay, so it will not change, it will remain the same. So say for example, you added 5 grams of catalyst at the beginning. At the end of the reaction, you will still have 5 grams of catalyst. Okay, the catalysts are not used up. Okay, this is because they are not part of the reaction. The catalyst is there just to find a way to decrease the activation energy. So they will never use up. So what's good thing about this is that you can reuse it to the next reaction. Okay, so using a catalyst, avoid the need for extra heat. Okay, as safer and cheaper. What does it mean? Okay, so say for example, I have here, let's go back here. Okay, so this is A plus B will turn into C, and here A plus B will turn into D first, and then the D will turn into C. Okay, so this is without a catalyst, this is with catalyst. Okay, so here, say for example, you need 1000 degrees Celsius here, and here you need 50 degrees Celsius, and then here you need 5 degrees Celsius. So here, for them to react, you have to increase the temperature. Okay, increase the temperature, otherwise they will never achieve 1000 degrees Celsius. So that's why this without a catalyst is not safe. Okay, 1000 degrees Celsius is very dangerous to deal. So that's why most of the time you need a catalyst, because a catalyst, you don't need to add temperature too much. Okay, you might add a temperature but not too much. You only need 50 degrees Celsius and then 5 degrees Celsius, so which is not too much. Okay, so that's why using a catalyst, avoid the need to extra heat, so that is safer and cheaper. They are used in industry, especially when an increasing in temperature results in a lower yield due to the shift in equilibrium. We did that before. Alright, so catalysts, these are the useful points. Catalysts are widely used in industry because they allow reaction to take place at lower temperature, so that saves energy because they have a lower activation energy. enable different reaction to be used, better atom economy, reduce waste. Actually, you don't need to know this. Don't copy this part. Are often enzymes. So this is biology. Enzymes are biological catalysts, okay? They work, enzymes work the same thing as a regular catalyst, okay? They lower activation energy and they are also not used up, okay? So they have a greater importance in industrial production. Catalysts are very important in producing polyethylene. We know polyethylene are very important in making plastics. Okay, sulfuric acid. Why sulfuric acid is sulfuric acid, so this is for plastic. Sulfuric acid is for fertilizer, and ammonia again is for fertilizer, and you know ethanol are for disinfectant. Okay, and then also catalysts are very important in catalytic converter. This is in cars. Okay, so they convert what toxic gas into less toxic gas. Okay, so the third, so we did two of the factor that increases the chemical reaction. The first one is increasing temperature. The second one is adding a catalyst. So this is now the third, increasing the concentration of the solution. Okay, again, I told you, when you increase the concentration, you increase the number of particles. Okay, so here they have less particle, this one have more particle, so which one will collide more? This one. Okay, so increasing the concentration will increase the chemical reaction. If they ask you why, because when you increase the concentration, you are increasing the particles. Okay, the more particles in the reaction is, the faster, the more collision, and if there's more collision, the faster the reaction. Here there's fewer collision, okay, because there's less particle. All right, when you increase the concentration, you're increasing the chemical reaction because more collision. Now let's go now to increasing the pressure of gases. So when you are increasing the pressure, let's talk about this one. Okay, so I have, when you increase the pressure, all right, what happened to the volume? Okay, so they decrease. Okay, so this one have a lower pressure, and this one has a higher volume. Again, when you increase the pressure, you have to decrease the volume. Okay, so this one have a higher pressure, lower volume. Look at their sizes. The volume, why do they do that? Yes. Okay, so the volume here is higher compared to the volume here. When the volume is lower, the pressure increases. So say for example, if you put 5 particles here and 5 particles here, which one will have a more collision? So more collision here. Why will they have a more collision and this one have a less collision? Why will they have more collision here? Because there's less space. Okay, less space. Why do they have a less space? Because they have a lower volume. Okay, so less space, less volume, more collision. Okay, so if you want to increase a rate of reaction of a gas, this only applies in gas. Okay, if you want to increase the rate of reaction of any gas, you increase the pressure. That means you have to lower the volume. Okay, because there will be less space and so more collision. All right, I hope that's clear. So say for example, this one, you are increasing the pressure, so more particles in a given volume. So this is a concentration, I think. Effects, so this is the, I think this is the last, the effect of light on chemical reaction. Okay, the effect of light in a chemical reaction, so such as photosynthesis. So photosynthesis, without a light, they can never occur. Okay, so not all reaction requires a light. Okay, but some reaction, it requires a light. So say for example, chlorine plus hydrogen to produce hydrogen chloride. For this to happen, you need to have a light. Okay, but not all reaction requires a light. Very, very few reaction requires a light. All right, so but this is one way to increase the rate of reaction. So say for example, this equation, this reaction, without light, they will never react. They will probably react after a million years. Okay, all right. So for now, I'm gonna give you a question. All right.